This video is on volume of solid, and I have this solid right here, and I'm going to use rectangular prisms to estimate the volume of this solid right here. And then to get the exact answer, I'm going to use the double integrals in polar coordinates to get the exact answer. And here we have the plane z equal to 5 minus x minus y. And then I have two circles on the xy plane. And then region R is the region that is in between the two circles. And I want to find the volume between region R and the plane z equal to 5 minus x minus y. And this is what the solid looks like. And now what I'm going to do is I'm going to estimate the solid that is between the region R and the plane with rectangular prisms. And so we're going to divide region R right here into many rectangles. And so here's one of the rectangles inside of region R, and here's the corresponding rectangular prism. And so for each rectangle, we have a rectangular prism, and the sum of the prisms, the volumes of the prisms, will be an approximation for the volume of this solid. And so right now, what I have is each rectangle here is 0.5 for the width and 0.5 for the length. And so the area of each rectangle will be 0.5 times 0.5. And then to calculate the height of this prism, I picked a point right in the middle of the rectangle right here. And then using so for each rectangle, pick the point right in the middle of the rectangle, and then use the function z equal to 5 minus x minus y to calculate the height for this prism. And so now what I'm going to do is I'm going to calculate the volumes of all the prisms that are inside of region R. And so if each rectangle has a width of 0.5 and a length of 0.5, then there are about 40 rectangles inside of region R. And so obviously many of the rectangles will be entirely inside the region R. And then some rectangles will be part of it is inside, only part of it is inside of the region R. And so there are approximately 40 prisms inside of region R, and the sum of the volumes of the prisms is 50. And so this is when the length and the width of each rectangle is 0.5. And so to get a better approximation for the volume of the solid, I'm going to decrease the length and the width of each rectangle. I'm going to make it 0.25. And so now the rectangles, you can see that they are smaller, and so the distance from here to here is 1, and there are 4 rectangles in here. And therefore each rectangle, the length is 0.25, the width is also 0.25. And this is what a typical rectangular prism looks like. And now let's find the volumes of all the prisms, rectangular prisms that are inside of region R. And so we have about 156 rectangles inside of region R, which is the region between the two circles here. So 156, and we get the sum of the volumes is 48.75. And now I'm going to make the rectangles, the length and the width, even smaller as 0.1. So if the length and the width of each rectangle is 0.1, then there'll be about 948 rectangles inside of region R, and the sum of the volumes is 47.4. Now I'm going to make it even smaller, so 0.05 for the length and the width of each rectangle. If the length and the width of each rectangle is 0.05, then there'll be about 3,760 rectangles inside of region R. And the sum of the volumes of the prisms is 47. And now let's go even smaller. And so when the length and the width of each rectangle is 0.1, then there are about 94,248 rectangles inside of the region R. And the sum of the volumes is 47.124. And then now I'm going to go even smaller, 0.005 for the length and the width of each rectangle. And if the length and the width of each rectangle is 0.05, and then there will be about 376,976 rectangles inside of this region R. And the sum of the volumes, 47.122. And so obviously if we want the exact answer, then we have to fill the region R, divide region R into an infinite number of rectangles. And so here's the last calculation that I did for the sum of the volumes of the prisms when the length and the width of each rectangle is 0.005. We got the sum of volumes of prisms at 47.122. And now what we're going to do is let n, or the number of rectangles, go to infinity. And so this will be the sum of the volumes of the prisms with n running to infinity. And then recall that before, just like before, and we define this as the double integral right here. Here's the double integral that we want to calculate. So to calculate the volume of the solid right here with region R between the two circles, what we can do is calculate the volume of the outer solid and then calculate the volume of the inner solid and then subtract. And then notice that for the outer solid, x will run from -2 to 2. This is the y-axis right here, and this is the x-axis. And so the part of the circle that is above the x-axis is going to have the equation of y equal to the square root of 4 minus x squared. And then the part of the circle that is below the x-axis is going to be y equal to negative square root of 4 minus x squared. And then the height will be 5 minus x minus y. And this is for the volume of the outer solid. And then the volume of the inner solid will be similar. Instead of a radius of 2, it's a radius of 1. And then now we can see that to actually calculate this double integral right here is going to be very, very involved, since it's involved the expression square root of 4 minus x squared and then square root of 1 minus x squared here. And so what we can do is set up the double integrals in polar coordinates instead of rectangular coordinates, and the double integral will be much simpler. And so to set up the double integral in polar coordinates, then notice that if we look at region R right here in polar coordinates, then this circle right here in polar coordinates, it will have the equation of r equal to 1. And then this equation right here, this circle right here, which has a radius of 2, then this polar equation will be r equal to 2. And since we're going from the entire circle, theta will run from 0 to 2 pi. And therefore the bounds for theta will be 0 to 2 pi. And then the bounds for r will be 1 to 2. And so f of r theta will be 5 minus, record that f of xy was 5 minus x minus y, and x is equal to r cosine of theta in polar coordinates, and then y is equal to r sine of theta in polar coordinates. And so this is what the double integral in polar coordinates looks like. So it'd be the double integral with theta running from 0 to 2 pi, and then r running from 1 to 2, and then the height function will be 5 minus r cosine theta minus r sine theta times r times dr d theta. And now let's evaluate the inside integral. So this is the inside integral, and then multiply this out, we get 5r minus r squared cosine theta minus r squared sine theta. And then notice that here we're integrating with respect to r. And so cosine of theta and r sine of theta will be constants. So the integral for 5r will be 5r squared over 2. Integral for r squared is r to the third over 3, and then same thing here. And then evaluating from r equal to 1 to r equal to 2, then we end up with 5 minus 7/3 cosine of theta minus 7/3 sine of theta. And so the volume of the solid will be the integral from 0 to 2 pi, and then with the expression 5 minus 7/3 cosine theta minus 7/3 sine of theta. And then evaluating, record that the integral for cosine of theta is sine of theta, and then integral for sine of theta is negative cosine of theta. So we end up with this, and then evaluating from 0 to 2 pi, then we get 15 pi, which is 47.1238. And so in summary, the volume of this solid right here with the region R between the two circles is 15 pi, or 47.123, recorded a few moments ago when I ran the program, the JavaScript program, with the length of the each rectangle of 0.005, and width is also 0.005. Then we got 376,976 rectangles inside the region R, and the sum of the volumes was 47.122, and we can see that it's very, very close to the exact answer. And that's the end of the video.